There are some interesting examples where we can find the solution of the Dirichlet problem. One example is the case when R is some rectangle and the boundary is given by these 4 lines where the temperature U is equal to 0 on the red part and is equal to some given function f of x on the green part. So what will the solution be in this case? The way of finding the solution is, as we did earlier, we are using the method of separation of variables. We write u of x, y equal to a product of 2 functions, one function which is only dependent of x and another which is only dependent of y. So recall that x is in this direction and y is in this direction. So using this we can differentiate 2 times with respect to x and we get this expression. We can also differentiate with respect to y 2 times and we get this expression, and we insert these expressions into the Laplace equation and obtain this equation. Dividing with f and g, the product of f and g, we obtain that as we did earlier for the wave equation, that this f double prime of x over f is equal to minus d double prime of u over g of u of y, sorry. And exactly as previously, we get that this function and this function must be a constant, because it's not possible for a function which is dependent of x to be equal to a function dependent on y unless these functions are constants. So as before, we get 2 equations. This. We do not go into so much details here, but let us just show you that making arguments very similar to what we did before, we arrive at a general solution for the temperature U, and it's written in this form. It's sigma n from 1 to infinity of un, where un is this product. In order to find this an star, these are constants which are dependent on n, we insert the boundary conditions. We use that for y equal to b, then this we know that we know the solution. We know that u of x b actually is equal to f of x. And rearranging a little bit, calling here we have just changed the order of the product here, and we note that this is a constant only dependent on n, so it's written like this, and then we realize that this is the Fourier series of the function f of x. So Bn must be the Fourier coefficient given by this integral. And we know that Bn is equal to this guy, so this is written here. And then we can just divide by sine hyperbolicus, and we get this expression for the the coefficient a and r. So summing up, we find that the solution u is written as an infinite series in this way, where the coefficients a and star is given by this integral